Suppose we have a distillation column where base level is controlled by tails flow, and feed flow is typically controlled by just a flow controller. In abnormal circumstances, if the tails flow is fully open but base level continues to accumulate to above a certain level, too high of a level, then we're going to need to cut back on steam naturally. Therefore, we need a high level override controller to override this flow controller in case the base level gets too high. We know that if we increase feed, we're going to increase base level, while if we increase bottom flow, we decrease base level. Since if we increase feed, we increase base level, and we need a high level override controller, we have a positive gain, and we have a high set point, so we need a low select function block, as we can see here. So we are not using a PI controller to control the override. As the override controller, we're using a function. This function is above 100%. This controller output is above 100% until the level gets to 75%. And then once you get above 75% base level, then it's going to be telling the controller output for the feed to start decreasing. So once the base level gets to 100%, it's going to tell the feed. So once base level hits 100% right here, it's going to tell the feed to start decreasing to 0. As you can see, we have 4 blue dotted lines. The first blue dotted line is the set point for the override controller for base level. The second blue dotted line right here is the set point for the base level controller, which is controlled by the bottom's control valve. The third blue line is the initial value for the bottom controller output, and the fourth blue dotted line is the initial value for the feed controller output. Each vertical red line is a different sampling period. At time 2, the level goes above the level controller set point, which causes the bottom controller output to start increasing. Since the level keeps increasing while bottom controller output is also increasing, the bottom controller output will eventually saturate at 100%. Base level will keep increasing, crossing its high level override controller set point, which will eventually cause this feed controller output to be overridden by this override controller. Since this is not a PI controller, the set point might not converge back to set point. It's more used to make sure the level does not get too high. However, there's also a chance it could converge to set point, but it's not guaranteed because you don't have this function does not have the integral component like a PI controller does, which will remove any offset. So this example was a high override level controller for a base level distillation column. The typical control variable for the manipulated variable, which is feed flow, was just to control the feed into the distillation column, but the base level was too high. With an abnormal condition, we want to protect the base level. We do not want to flood the column. Therefore, you have an override controller to control the feed rate in case the base level gets too high. I hope this example helped, and I hope everyone has a good rest of their day. Thank you.